Welcome back to my channel. Today we are going to be looking into linear equations in one variable. Yes, the topic might look easier, but you'll be very surprised when you see the challenges students are facing in order to solve a linear equation. Some students don't even recognize if a linear equation is of one variable or is of several variables. Today, we're going to look into that. So today's video, we will learn how to solve for simple linear equations with this easy to follow tutorial. This video also breaks down the steps to solve variety of linear equations. And I will also cover all you need to know from basic to more complex equations. Let's go into today's business. How do we define linear equation? Or what is linear equation? Linear equation basically means an equation in a straight line. A straight line means that it is on a straight form. Linear basically means straight line. If I have equation, your equation must have this equals sign. The equals to sign must be in your equation. When there is no equal sign in the equation, that is an expression. Therefore, what does equation tell us? It tells us that the left-hand side must equal to the right-hand side. This is equation. Equation is telling us that the left-hand side must equal to the right-hand side. That is one thing to have. Now, we can also represent linear equation in form of a slope. In that way, we have to think about the general equation of a straight line. What is the general equation for a straight line? The general equation for a straight line is y equals mx plus c. This is the general equation for a straight line. Then we have to describe this equation. If you are to describe this equation, here x and y are variables. X and y are variables. M in this equation is the slope. Y, c is the intercept. C is the intercept, or it is also called a constant. So let's quickly delve into the meaning of slope. We're not going to go too much into the slope, but we just have to just quickly brush it up so that we can refresh our memory. Slope is defined as the rate of change, and it tells us how much one variable affects the other variable. In this case of this equation, the slope here tells us how much x affects y. In that way, let's quickly look at this graph. This graph tells us more about the slope. If we have this line plotted, maybe this line is plotted, this is an example of a straight line graph. In this graph, we can find the slope of this graph. We can find the slope of this graph. For example, if this is the y-axis and here is the s-axis. So the slope here, like we said, that slope tells us more how much the x affects y, and it is also the rate of change. The rate of change is denoted with this sign. We have the rate of change of y over the rate of change of x. This is the y-axis. The rate of change of this y, let's say this is y2 and this is y1. The rate of change of this y is y2 minus y1. That is the rate of change of y over the rate of change of x. So if this is y2, this will be our x2. If this is y1, this will be our x1. We have to be very, very careful with that, because your y2 must go with x2, y1 must go with x1, divided by x2 minus x1. So this is what is called the slope. The slope is telling us how much this x affects y. That is the slope. So if you look at this example, I'll be using my red pen for the examples. Example, if we have y equals 5x plus 10. Y equals 5x plus 10. Don't forget that we define slope as the rate of change, and also we said how much x affects y. It is what we call the slope. Now, if we increase x by 1, what happened? If we increase x by 1, what happened to y? What happened to y is that if x is increased by 1, y is always increased by 5. Why is this so? Because if you equate this example with the equation of a straight line, we have y equals mx plus c. Look at that. That shows that m equals 5. C equals 10. C is the intercept. M is the slope. And that is the reason whenever x is increased by 1, y is increased by 5 because of the slope. It is the rate of change. For example, if x equals 1, what will happen to y? Y will be 5. Whenever we see x, we put in 1. 5 into 1 plus 10. And that one will give us 5 plus 10 to give us 15. Let us look at it. If x is equal to 2, in that way, what happened to y? Y will be 5 into 2 plus 10. And that will give us 10 plus 10 to give us 20. If x equals 3, how does x affect y? Y will now be 5 into 3 plus 10. And that will be 15 plus 10. That will give us 25. You can see that whenever x is increased by 1, y is always increased by 5. Y increases by 5. Now, we can use this to go into linear equations in one variable, because we already know the definition of linear equation, and we relate linear equation to the general equation of a straight line, and from there we were able to define the general equation of a straight line, and we said slope is the rate of change of y to x, and we look at the examples under that. Now, what can we say about the linear equations in one variable? Linear equations can have many variables. It can be one variable, it can be several variables. But today we are looking at linear equations in one variable. Before we do that, we have to look at the conditions under which linear equations is one variable. Now let's look at the conditions. We have two conditions under that. Conditions for linear equation in one variable. The first one is that equation, for any equation, these conditions for any linear equation in one variable, these conditions must be met. The first one is that it must have one variable. It must be what? It must have one variable. The second one is that the highest power of variable must be 1. highest power of variable must be 1. That is very, very important. So what do we mean by the highest power? Highest power is the power in which that variable is raised into. It is the power in which the variable is raised to. So these two conditions must be met for a linear equation in one variable. In that way, we can then define linear equations in one variable. An equation is called a linear equation in one variable when the highest power of variable is 1. You can see that these two conditions are already met, that for you to say an equation is linear in one variable, it must be what? The highest power of variable must be 1. Example. Let's quickly look at example under that. If we have 2x plus 10 equals 20. 2x plus 10 equals 20. What does this equation tell? What does it tell us? As we can see, we want to check if it is a linear equation in one variable. But what does this equation, what does it tell us? What this equation tells us is that x is the variable. X is the variable to be found, or x is the variable to find. That is what we are looking for, is the variable to find. Then this is the left hand side, this left hand side, and this is the right hand side, meaning that the left hand side must be equal to right hand side. The left hand side must equal to right hand side. These two conditions must be met under linear equation in one variable. That is what the equation tells us. What this equation tells us is that x here is the variable to find, and the left hand side must equal to the right hand side. Good. If we have seen that and we already know what it means with this equation, and that we saw that the highest power of variable here is 1, because this is the variable, the highest power is 1, and we define the highest power as the power that the variable is being raised to. This is raised to 1, raised to power 1. We don't normally write when it is raised to power 1. So this is a typical linear equation in one variable. Now, we have already talked about the conditions, and we said we have two conditions. Now, let's go into way to analyze equation. How do we recognize that this equation is a linear in one variable or several variables? We're going to analyze this equation. The first one is 3x plus 4y plus 2x equals 0. Another one is 10a plus 20c equals 50. Another one is 2x plus 10 equals 20. We have another one, 2s cubed plus 2s squared plus 10 equals 20. And we have 2 plus 3x equals 1. So if we look at these equations, I can have one more. If you look at these equations, we can easily know that there are some that do not meet the conditions under linear equations in one variable. And we know the reason now. We should be able to know that this equation is a linear equation in one variable or not. The first one is not. We want to analyze this equation. Maybe they are linear in one variable or not. The first one is not, and we know the reason. The reason is that this is having two variables. So it is not. Even though the highest power of variable here is 1, here is 1, here is 1, but we are having two variables. So this is not a linear equation in one variable. If you look at the second one also is just like the first one. This is having two variables in A and C. Two variables in A and C. So this is not. If we look at the third one is having one variable, and the highest power is 1. The highest power is of the variable is raised to power 1. So this one is one variable and highest power of 1. So this is a good one. If you look at the fourth one is 2x cubed. Because of the cube, the highest power must be 1, but the highest power here is 3. The highest power here is 2, even though it has one variable. So highest power is not 1. In this case, this is not a linear equation in one variable. If you look at the fifth one is yes. And the reason is that one variable and the highest power is 1. The sixth one is two variables, even though this is 2 highest power but one variable. 2 highest power but one variable. So it is not. So we can see that 3 and 5 are linear equations. 3 and 5 are linear equations in one variable. The rest are not. The rest are not. So these are more examples in which you can use that to, you can try this. What I will do is I will just pause this video, try this and see if you'll be able to get this. So in this way, you are going to look at how many highest power of variable and look at how many variables do we have in there, like the way we did this first, the way we did this one. So the first one, if we have 10x squared plus 5x plus 2 equals 8. Another one, 3 plus 2k equals 9. We have 2a plus 3b equals 4. And we have the fourth one, 5x plus 6s cubed plus 1 equals 3. So try to do them and see if you are getting it right. So the next topic we're going to look at here is how do we solve linear equation? How to solve linear equations in one variable. How do we solve linear equation in one variable? I'm pretty sure by now everybody should know about linear equations. You should be able to know to differentiate between linear equation in one variable and linear equation in several variables. Lest I forget, please, if you have not subscribed to my channel, please kindly subscribe to my channel so that we can enjoy our teaching, and every time I upload my videos, you will be notified and the video will get to you immediately. Thank you very much. All right, let's look into how we solve linear equation. The first one is, I will pick from this example, the example that said 3 plus 2k equals 9. I will go into 2k plus 3 equals 9. This is a typical linear equation in one variable. So I want you to understand this and put this at the back of your mind, these properties. The first one is additive inverse property. additive inverse property. And the second one is multiplicative inverse. Multiplicative inverse. Multiplicative inverse property. And the third one is distributive property. Distributive property. We're going to see them and we're going to talk about them as we continue solving the examples. So the first example is 2k plus 3 equals 9. So what should we do by the time if we find ourselves in this challenge to solve 2k plus 3 equals 9? The first thing I would do is I would collect the like terms. I will collect the like terms, which is the same way by saying that you add the additive inverse of plus 3, because what we are asked to find, as we have already defined the equation, the linear equation, we defined that the other time that this k here is a variable and it is what we are asked to find. And it must also have equal to. And the left hand side must always equal to the right hand side. Once you know all these three, the first thing to think about is that you want to find k. So if you want to find k, find a way to eliminate plus 3 here. Eliminate plus 3 here does not mean that we're going to trash it. Eliminate in the sense that take it away from the variable. That is why I said what I would do is to collect the like term. If you know that at the back of your mind is collect like terms. So what does that mean? That the one that are similar, put them in one side. The one that are not similar, put them in one side. You will see that 3 and 9, they are similar. Put them together. Take it away from this variable. In that way, that is when we now talk about the additive inverse. Additive inverse of plus 3 is minus 3. Some students will now say add additive inverse of minus 3 to both sides. So plus 3, the additive inverse of plus 3 is minus 3. That means that what this is saying is that we should add additive inverse minus 3 to both sides. So if we do that, we have 2k plus 3 minus 3 equals 9 minus 3. That means I have added the additive inverse to both sides. If you look at this, 3 minus 3 cancel out. So we have this as 9 minus 3. So we are left with 2k. We now equal to 9 minus 3. Which is the same thing when you collect the like terms. When you collect the like terms, you are taking 3 to where it belongs. You are taking 3 to where it belongs to. And where does it belong to? It belongs to where we don't have the variable. And when you are taking plus to the other side, it becomes minus. So this plus is going into the other side. So we now have 2k. There's nothing here again because the plus 3 has moved into the other side to become minus 3. And that's what we have here. 2k equals 9 minus 3. So we continue. So we have 2k. We now equal to 6 because 9 minus 3 is 6. So the next step is that we're going to multiply both sides by the multiplicative inverse. We're going to multiply both sides by multiplicative inverse. Multiply both sides by multiplicative inverse. So you can see we have used the additive inverse and we are using the multiplicative inverse now. And what is the multiplicative inverse? Because we need, this is the variable, and that is what we are looking for. We are asked to find k, not 2k. We are asked to find k, not 2k. So we have to find a way of get rid of these two. And how do we do that? If we multiply the multiplicative inverse to both sides, and multiplicative inverse of 2 is 1 over 2. Multiplicative inverse of 2 is 1 over 2. So we're going to multiply them together. 1 over 2 multiplied by 2k will equal to 6 times 1 over 2. The reason we are doing them for both sides is that we have not done anything. If you look at it, there's nothing done to them because 1 over 2 equals 1 over 2. So 1 over 2 equals 1 over 2. It doesn't make any sense because there's nothing added and there's nothing removed. So in that way, 2 here 1, 2 here 1. So we are left with k equals, this will give us 6 over 2. So k will now be 3. And that is our final answer. That is our final answer. I'm pretty sure we understand this very well. Please have this at the back of your mind that additive inverse goes with subtraction and addition. So it means that subtraction is an additive inverse of addition, of which we have seen here that subtraction is an additive inverse. When you hear additive inverse of plus, it is minus 3. It is minus. So let's look at the multiplicative inverse. Division is the multiplicative inverse of multiplication. Division is the multiplicative inverse. Is the multiplicative inverse of multiplication. I'm sure we understand this, that subtraction is an additive inverse of addition, while division is the multiplicative inverse of multiplication. That's why when we want to cancel out these two, we multiply by 1 over 2, the inverse of 1 over 2. So multiplication, division, they go together. Addition, subtraction, they go together. So we're going to look into another example. So I'll say this is example 2. In that example 2, if we are how to solve for x in x plus 8 equals minus 3. Solve for x in this. If I were you, I'll pause the video and quickly solve this and tell me the answer to this. So in that way, what we have to do the same way is, if you don't want to go in a way of collecting the like terms, you can say, because this is your variable, you should know that this is your variable and that is what you need to find. This is your variable and that is what you need to find. So you're looking for a way to get rid of this 8, in the sense that you want to take the 8 to the other side to collect the like term. I will collect the like terms, and if I want to do that, I'll take 8 to the other side. But we can also do add additive inverse of plus 8 to both sides. And what is the additive inverse of plus 8? It is minus 8. That means we're going to add minus 8 to both sides. We have 8x plus 8 plus this will equal to minus 3 plus minus 8. Or you may put it here. Don't let me, it's fine, it's fine. You can write it the same way I used to write, like, you can write the same way I used to write x plus 8 minus 8 equals minus 3 minus 8. And what do you see in there? These 8 cancel 8. You have x will now equal to minus 3 minus 8. X will equal to minus 3 minus 8. So the same thing here. This cancel, this cancel. We have x equals minus 3. And I've already thought about this before, that whenever you're having minus in the bracket, by the time you open the bracket, it becomes minus, because that minus is stronger than the plus. So we have minus 8. So here our x equals minus 3 minus 8. In the explanation, you are owing $3 and also you are owing another $8. So the total money you are owing is $11. So you have x equals minus 11, and that is the answer to the question. Then we can also see, because it's one of the criteria, that the left hand side must equal to the right hand side. So if you have x plus 8, we're going to check. We want to check x plus 8 equals minus 3. And what is x? Just replace x with minus 11. So we have minus 11 plus 8 must equal to minus 3. You are owing somebody $11 and you have $8. So if you pay that person $8 out of $11, so you have minus $3 to pay to the person. So minus is always what you borrow. It's the money that does not belong to you. You borrow it. So this is minus 3 equals minus 3. And that shows that the left hand side is equal to the right hand side. Isn't it great? Yeah, we are doing very, very good. We are doing very, very good. Can we look at another example under fraction? Let's look into other example under fraction. Example 3. Example 3. What if we have 3 over 4x equals minus 2? Find x. If you have 3 over 4x equals minus 2, find x. So what you should think about is that because we are having this fraction, this is an example for a fraction, you can go in many ways. But what should come into your mind is that this is your variable. X here is a variable, and you want to make sure that you find that variable. So what do? Anything associating with that variable should be sent to the other side, should be sent away. Now, how do we do that? Because we already said that the division is the inverse of multiplication. Likewise, multiplication is the inverse of division. This is a division. So in that way, we have to multiply both sides by the multiplicative inverse. By the multiplicative inverse of 3 over 4. And what is the multiplicative inverse of 3 over 4? It is 4 over 3. That means we're going to multiply both sides by 4 over 3. So we do that. 4 over 3 times 3 over 4x we equal to minus 2 times 4 over 3. That's good. So from here, 3 cancels 3, 4 cancels 4. So we are now left with x equals, just multiply the top and the top together. Just multiply this with this. So that will give us minus 8 over 3. And the answer is going to give us x equals minus 8 over 3. We go into a more complex equation. Complex linear equation. So example under that, if you are given that 3x minus 6 equals 2 into bracket x plus 10 minus 4x. Solve for x. If you are given 3x minus 6 equals 2 into bracket x plus 10, close the bracket, minus 4x. Anyway, the first thing you have to do in this is to open the bracket. You open the parentheses, solve that first, so that you make sure that your equation is solvable and is on linear equation. So we're going to do that. We have 3x minus 6 we equal to, now we're going to use these two to multiply this out, and that is where the distributive property comes in. You're going to use this to multiply this out. You distribute these two into x and 10. So if you do that, 2 times x will be 2x. 2 times 10 will give us 20. That will give us 20. So minus 4x. We are doing great, right? Fine. So in that way, we are turning that complex, a little complex, we are turning it into a simpler one. So having done that, the next thing to do is to collect like terms. Collect like terms. Like I used to say, collect like terms. What does it mean by collecting the like terms? Those ones that have letters or the one that has alphabets, put them together. Those ones without alphabet, separate them. Put them, the similar figures, put them together. That is the essence of collect like terms. So if you look at the 3x, 2x, 4x, let's put them together. 3x, 2x, 4x. We want to put them together. But what you do is start from here. 3x. Don't bother yourself with this minus 6 first, but start from the first one. So that means we are starting from the variable. We have only one variable. We have only one variable, and the power in which the variable is raised is 1. So this is a typical linear equation in one variable. So in that way, if I have 3x, these 2x, I want the 2x to go into the other side of the equation. And we have over here, there is an invisible plus here. So when it goes to the other side, it becomes minus. I will take this to the other side. So it becomes minus 2x. So the next one is 4x. And over here is having minus. So when it's going to the other side, it becomes plus. So we have plus 4x. Now, I will now write my equal to, because I've already selected my variables in one side. So these other ones are not my variable. So in that way, what do you have left here from the right hand side? You have already taken 2x to the other side. You've taken 4x to the other side. What you have left is 20. Write it down. 20. But on the left hand side, you have minus 6. So you take that minus 6 from the left hand side to the right hand side. And this is having minus 6. When it goes to the other side, it becomes plus 6. Do not forget the sign in front of the number. Whenever the number is moving, they go together. But the difference is just that when the number is crossing, when you have equal to in between them, and the number is crossing from one side to the other side, the sign changes. And that's what we have done here. So now let us now look at what we have. We have 3x minus 2x plus 4x. That means 3 minus 2 plus 4. 3 minus 2 will give us 1. 1 plus 4 will give us 5, right? So we just say 5. Then put their variable at their side. So we have 5x. In the same way, 3x minus 2, I didn't do anything different. 3x minus 2x plus 4x will give 5x. Only that I'm making it easier by neglecting their variables. First, look at the numbers to make it easy. 3 minus 2 plus 4, I got that as 5. Then the variable, I put it by the side. So which will equal to 20 plus 6 to give 26. So the next thing we have to do, because we are asked to find x, not 5x. Be careful with that. We are asked to find x, not 5x. So the next thing what we have to do now is to multiply both sides. Multiply both sides by the multiplicative inverse. Multiplicative inverse of 5. And what is the multiplicative inverse of 5? That one we give 1 over 5. So we now use 1 over 5 to multiply both sides. So we have 1 over 5 times 5x equals 1 over 5 times 26. So 5 cancel 5. We have x equals 26 over 5. You can leave your answer this way. You can also go as saying x equals 5 in 26, we give 5. Remainder 1, because 5 times 5 is 25. So we have 5, 1 over 5. You can leave your answer in this way or this way. So that is another example, a very complex example. And I think that we'll be stopping here. Maybe in the next class, we can continue with some of the complex examples that we can meet under linear equations in one variable. But before I go, I would please subscribe to my channel. Please subscribe to my channel so that whenever I upload some new videos, you'll be notified and you can get them. And if you help my channel in order to grow my channel, thank you very much for watching my video. I will see you in the next one. Bye.